It's my pleasure to introduce Oliver Campbell today. Oliver is a PhD student at Cardiff University, and he's been working on the role or the geological heritage or heritage conservation and how geology can be used for this, and that's going to be the topic of his talk today. So I'm just going to stop sharing my screen, and then that should give you the opportunity, Oli, to unmute yourself and then start sharing your screen. And just maybe you do just ask whether it's working, and I can give you a nod.
Can you see my presentation now?
So I can see you and I can hear you.
Hang on. Is that working?
Yeah, it's working. I think it's coming through. Yeah, very good. I can see it. So okay. Yeah, the stage is yours. Yeah, thank you very much for this talk.
Sweet. So hi everyone. I'm Ollie, and I'm a PhD student here in the school, as David said. And today I'm going to talk briefly about my research and how, as a structural geologist, I'm involved with conflict-affected heritage and conservation efforts. So before I begin, I do need to mention that my work is part of a larger project called Heritage in the Crossfire. I work with a number of really great people from a range of institutions around the world. And you can find out a lot more about their work and my work at our website. So a shameless plug for heritageinthecrossfire.com. And we put up sort of resources and presentations and things like that. So if you are interested in what we're doing, do go check it out. And in the bottom corner is my Twitter and my email address. So feel free to follow me there and email me any questions that you may have in future. So to break down my talk, it's going to start with a little of the why the project came to be and the issues that it hopes to address. I'm going to talk a bit about what conflict damage looks like and how we can recognize it. Then I'll discuss how this might affect heritage in the long term. And then to finish, I'm just going to talk about one of the methods that I've been using in trying to sort of develop to answer these questions. So conflict is nothing new to humans, unfortunately. And the intentional destruction of culturally significant sites is a staple tactic throughout history. On the left here, we have a depiction of the Persians sacking the Acropolis in Athens in 480 BC. And their only real tools were sort of handheld weapons, fire, and sort of manual dismantling and toppling. And this requires significant effort to cause the serious damage that archaeologists have found. And then in the middle here, we have one of the Buddhas of Bamiyan in Afghanistan, pre-2001. And these 6th century carvings were at the time the largest standing depictions of Buddha anywhere in the world. But in 2001, the Taliban systematically destroyed them with various explosives and large caliber weapons, taking significantly less time to completely erase most of the site that had been there for thousands of years. Thankfully, I think there are efforts now to sort of rebuild them and reinstall them, but I don't know what stage those are at. And these graphic and targeted events have become more mainstream during the rise of IS in the Middle East and North Africa. You may have seen videos of Palmyra in Syria, but there is another form of conflict damage that is far more common and is found beyond these regions. And that's ballistic damage. So small-scale ballistic damage is essentially any projectile that has some degree of momentum hitting a target. And so sometimes this is intentional vandalism using firearms, but more often than not, they're an unintentional consequence of conflict. Explosives often produce large amounts of projectile shrapnel that hits more than just the intended target. And with modern small arms capable of firing up to 100 rounds a minute, there's a lot of bullets that miss their target and hit other buildings. And so here I have some various examples from my work. On the left is a picture from the Royal Garrison Church in Portsmouth. That was damaged in a bombing raid in 1941. The main building at Cardiff has lots of impacts around sort of the edge of what is now the car park, but was the tennis courts from raids in February 1941 and March 1941. These particular ones were from the raid in February, where 4 high explosive bombs landed in what is now the car park of the main building and damaged a lot of the facade, windows, and caused damage to the library as well. Here we have some bullet impacts from Qasr al-Azraq in Jordan. And this was a site where Lawrence of Arabia and his Arabian comrades stayed. And so we believe these will sort of form part of what looked like a target practice range on the inside of the castle. And here's just an impact that I created in one of my experiments. And I sort of use all of these to link together in my research. So why do we look at these relatively small impacts when explosives and targeted demolitions are destroying whole sites? Well, we found from initial experiments that the damage goes far beyond the visible surface cratering and fractures that we can see. So this image here is a CT scan through a sandstone block. And the scan is essentially just an X-ray machine for rocks that allows me to look at slices within the rocks and image them without having to cut them up. And the slice here is through the middle of the block. And the path of the bullet is kind of into the screen, as if that laser pointer is kind of the target. And so I've highlighted several fractures, which we can see go deep into the stone, but some of which aren't visible at any of the superficial damage. And additionally, there's a big gap in the research about the interplay of multiple impacts and how they influence stone properties. For example, if I have a small patch of rust on my car, I might not be worried, but if I have enough patches of rust, or that rust is in particular places, then the collective effect can be quite severe. And so the thinking is that although these impacts in themselves might not be that consequential for the structural integrity of a building, actually lots of them or impacts in certain positions can cause severe effects to our heritage. And this research gap also means that sites cannot be fully repaired or protected effectively if we don't fully understand how they're damaged. So poorly informed actions can actually lead to worse decay and damage compared to sites just being left alone. So to really emphasize the damage that these small caliber impacts can cause, I'm just going to show this clip that I show all of the time, because it really demonstrates clearly the damage potential in such a short space of time. So hopefully this will play. It'll work. Oh. 1 second. There we go. So hopefully you can see this. And so for instance, this full clip that I'm showing you is about the length of time that it takes you to blink. And so what's really important is the way these fractures rapidly propagate deep into the stonework. And then you get this quite impressive ejection of material from the center of the crater as well. And so what do these ballistic impacts look like? We've had a quick glimpse of them in the previous slides, and there are a number of variables that affect the shape and the look of the damage. There are, however, a few general characteristics common to most impacts that help us identify them. They tend to be roughly sort of circular in shape, but this can be affected by how uneven the original surface is. It can also be influenced by how close these impacts are to the edges or corners, or whether they're on flat walls or columns. They have a steep-sided sort of central region, shown here in red, which is caused by the penetrating action of the projectile. And then they have a shallower outer region, which is formed by the reflection of stress waves within the stone from the impact. And with both of these, the impact energy, the trajectory, the stone type, and all of these properties play a role in the shape that these impacts have. These zones are more consistent with bullet impacts because of the uniform shape and trajectory of the projectiles. Shrapnel impacts have a non-uniform shape an unstable flight path. They're sort of tumbling, and they have no real kind of, they're essentially treated as sort of random flight paths. And so this leads to a lot of variation in the impacts that shrapnel causes. But common to both of them is radial fractures emanating from the sort of central region, a bit like spokes of a bike wheel. So how does this affect heritage? When a stone is left exposed for long periods of time, it can develop what we call a weathering crust. This is where the surface of the stone only weathers to a certain depth, and then this kind of crust protects the stone below from any further weathering. In this example, the weathering crust is this deep red brown color caused by iron minerals in the surface reacting with the atmosphere. And these bullet impacts have punched right through that crust, not only exposing the fresh rock beneath, but also increasing the surface area of rock that is now is open to the elements. And we can also see quite nicely these radial fractures coming out from the impact, and sort of joining up to the other impacts. And all of these factors play a role in how this stone is going to weather in future. So the stone itself is comprised of grains such as quartz and other minerals, and a matrix that acts as a glue binding it all together. And the fractures not only break the grains in the matrix materials, as we see in these pictures, these pale regions are sort of open fractures. They're breaking the boundary between grains and the matrix. There's points where they go through grains themselves. But these open fractures then provide a pathway for moisture and other agents to travel deep into our stone. This is problematic because this moisture can contain dissolved minerals that are going to react with the stone in a negative way. An example of this is the Royal Garrison Church in Portsmouth, which I mentioned before. And so the formation of these black deposits in a lot of the craters, in some of the fractures, is due to the high salt content of moisture in the church, which predominantly comes from sea spray, but also from the salty groundwater, reacting with air pollutants to form gypsum. And as this gypsum deposits form, they pry apart the grains between the crust and the rest of the rock. And eventually this crust becomes heavier than sort of that bond to the rock can cope, and these crusts fall away. So they're very delicate. And so this crater, you can see here, all of this material has recently come loose. And again, here, this section has come loose. And now this bare stone is able to start reacting with the atmosphere again and with moisture, and deposits will presumably begin to grow here. And over time, this cycle continues the progressive deterioration of the stonework. And so some of our research is focused on processes like this. And by doing so, we hope to understand sort of the timescales and the severity of weathering and the threat that it poses to sites of cultural significance. So on to kind of the methods that I use. Just one of them. I'm particularly interested in the fractures that form and what links we can make from the surface damage, so the internal fractures and damage that we can't see on the surface. So I've just brought back this CT scan from one of the experiments. And so this is the original scan on the left. And on the right, again, it's that image with the highlighted fractures. And again, bullet travels into the screen. And so we see these fractures kind of fall into sort of two groups of orientations. We have these kind of left to right horizontal ones, and then these kind of up down semi-vertical fractures. And what we hope is that through looking at the surface damage, we can make inferences about this internal damage. And so how I do that is through a method called photogrammetry. And so what I do is I take a lot of pictures of the damage and I use that to create a 3D model, which looks something like this. And so this black arrow is the bullet trajectory, and this broken surface is the same as this surface in this very colorful image here. And so what I've done is I've then broken down this surface into a series of smaller surfaces, because the theory is that the morphology of damage we see here is an expression of the fractures interacting with one another. And so if we can categorize those fractures from this surface, maybe we can make inferences as to what the damage is internally. And so from this colorful image, the color represents the orientation of the plane, and the intensity, so the brightness essentially is the amount of dip. So we have, again, we can kind of see a step-like morphology in our model, which is reflected in our surfaces. And so we have these bright, very steep, sort of north dipping faces, and then these grayer, less intense sort of groups here, here, and here. These are kind of the horizontal, if you will, shallow dipping things. And so then what we can do is we can take these planes and we can plot them in what's called a stereo net, which is this potentially complicated, very colorful, again, looking diagram. But what this basically shows is we have these steep dipping group of surfaces, and then this shallower dipping called a step-like morphology. And so the working hypothesis is that we can potentially use this non-destructive technique where we don't have to damage the stonework. You know, we're not causing any artificial deterioration at the site, and potentially link that back to these sort of groups of fractures that we can see within the stonework itself. And so the hope is, through our series of experiments, we can build up this relationship and to see you know, how solid that relationship is. So once you know what these impacts look like, you actually start to notice them around quite a bit. So the UK itself has quite a lot of historical impacts left over from the Civil War, as well as I've shown, bombing damage from World War II. And so I'd love for anyone to send me any pictures that you think might be conflict damage to my Twitter, which is just @BritOutofPlace. Use the hashtag #ShotOrNot, because I'd love to see them. I'd love to research into them and see what I can find out about them. But if you don't have Twitter, feel free to email me any pictures or sites that you think might have damage that might interest me. And I'm happy to answer questions on either my Twitter or my email. And so thank you for listening. I just want to thank the Hazel Pritchard Prize, English Heritage, and the Leave Hume Trust for funding and access, and COTEC for facilitating our experiments. And then I'm just going to leave you with my final message, I guess, which is that even when conflicts are over, damage to our heritage and buildings can have lasting effects. And we as geologists can have a role in understanding that. And that's it. Thank you very much.
Thanks a lot, Ollie. Quite an interesting talk. Not the sort of traditional research that you might associate with geology, but definitely something that has some significance. I'm just going to have a quick look at the Q&A panel. So here's just a question that has come through, which I'm going to read for you, and then everyone also has an understanding of what is the nature of the question. So the first question is, are there any plans to use this information to formulate processes of covering the cracks and internal damage? I think it's a great question. I had something very similar in mind for you.
Yeah, so within the current research that we're doing at the moment is purely understanding the damage and characterizing the damage, with the hopes that someone can use that to formulate a process of repair if that is what is deemed necessary. I know at University of West of England in Bristol, they have started a project looking at microbial self-healing crack processes in limestones. They're using some sort of microbes that precipitate calcite to kind of repair limestone cracks and things like that. I don't know what stage they're at with that and how successful it is. but a lot of the thinking around this is some sites will want to kind of remove the damage and repair it completely. But some sites want to retain that damage because it has become part of the history of that site. For example, the Royal Garrison Church hasn't repaired any of theirs because it has such intrinsic links to the military in the city that they have decided to sort of, that is now part of its history. They've left it open. They've left the damage there. They've repaired the chancel, but the nave and most of the church is still there, and it's all essentially left untouched since the bombing, because they deem that as part of now the church's history, and it's itself has become part of the heritage. Hopefully people will use kind of the data we put out to inform their heritage kind of conservation needs.
Yeah, definitely. Yeah, thank you very much. Yeah, it's good to know actually there are possible plans to kind of heal these damages, but also importantly, they are now also considered part of the heritage, as you said. So there is no other question from the participants, but I have another question for you. So is there a kind of a list of the sites that have interesting impact marks that the general public could visit and see? Because we often go to places to look at beautiful things, but perhaps people more interested in historical features might find interest in visiting sites with bullet impacts or bomb impacts, anything that could essentially provide a testimony of some of the history of the UK, or it could be other places, I don't know.
There's no sort of comprehensive list or anything like that. There are we mentioned some sites that we've worked on and researched on our website and that are referenced in some of the previous works that members of the group have done. I believe there is a English Civil War site that has a list of a lot of sites that were involved within the English Civil War, and a lot of those are now heritage sites, and so have been preserved, and so will have sort of musket damage, cannon damage, that kind of stuff from the Civil War. But I don't know how extensive and full that list that they have is. So if people are interested, yeah, certainly check that out. But yeah, when you're out and about, keep an eye out for them. If you're at an old church or sort of old castles and things that are of the age of the Civil War, then you can certainly see these things. And then once you have a specific site, it's very easy to sort of go and Google the history of that site and find out more about what happened there.
Yeah, great. So I think it's very important that you mentioned that anyone can contribute to this sort of research. It's important actually to identify the sites where there might be something interesting to study. But if it's just the work of a few researchers, even though they are generally very dedicated and motivated about the research, that might take years to come up with some interesting examples. So yeah, as Ollie has said, if you think there is anything interesting in your area, don't hesitate to contact him. That would be
yes, please do.
very good. That would be excellent. There is yet another question. I think it's going to be well, actually, a couple of questions. A very short one here. Are there any of the castles in Wales on the list of heritage list, I guess, with some potential marks or impact marks?
Honestly, I don't know. I have my task for the near future now. I can get up and about is actually see what is now within traveling distance to look at, because overseas field sites have been limited. So I can't answer that question now, but
yeah, fair enough.
I mean, if you follow me on Twitter or follow the site, then I'll definitely try and find out and see what sites I can find.
Yep, very good idea. A third question is: Are you building a database of the variation in damage to different building materials caused by a similar depth of damage? That is, some damage can be ignored, but some damage might be more structurally significant.
So yeah, yeah, my project's kind of, trying to look at how can we characterize the damage and assess how important it is in terms of work that needs to be done. As far as an established database goes, I don't think it'd be anything that expansive yet. But yeah, the idea is certainly to understand how certain stone types, at the moment we're only really limited to sort of limestone and sandstone because of the project constraints. But yeah, look at how the surface damage relates to the internal damage. And then, if try and come up with a scheme of assessing that damage in a non-destructive way, and then using that to inform on whether it will be significant structurally and need to be repaired, or if it is purely an aesthetic thing that is near surface. So that's definitely the goal. And I mean, everyone has idealistic sort of outcomes for projects and research, and certainly that would be an idealistic outcome, that we had this database and you could go to a site, simply assess what's visible and be able to quantitatively kind of say where is at risk and where isn't. But yeah, thank you for the question.
Thank you, Ollie, for this answer and for the talk in general. I think that was the last question, and we're coming to an end of the GeoTalk today. So thanks again very much for your presentation. Thanks a lot to all the participants. That could not happen without you, obviously. And if you like these events, don't hesitate to spread the word. There is hardly any limit on the number of people we can actually accommodate in these GeoTalks. So as we often say, the more the merrier. So spread the word, please. And I'm going to see you next week. We're going to get a little bit away from heritage conservation. We're going to talk a little bit more about earthquakes. Ake Fagerang talked about earthquakes in the ocean last week. Next week, Oliver Francis is going to talk about earthquakes, and is going to give an example from the 2008 Wenchuan earthquake in China. He's going to talk a little bit about the relationship between earthquakes, landslides, and rain. So I hope to see you, or at least see your names in the participant panel next week. And until then, keep safe. Goodbye.